So we'll get into some application problems using right triangles. So I'm just going to go through a few of them with you. If we are given that the hypotenuse of a right triangle is 4 inches, so here's my right triangle, and I know the hypotenuse is 4. If one leg is 2 inches, find the degree measure of each angle. So I know that this is 2, and I want to find the degree measure of each angle. Well, I don't know what this side is, and I don't know what this angle is or what this angle is, but I can say that this is just angle X. Okay, so I'm going to say that the sine of angle X is going to be 2 over 4. So it's going to be opposite over hypotenuse, and that reduces actually to 1/2. And if you'll remember, that's a benchmark angle. So from the unit circle, I know that the sine of 30 degrees is 1/2. So I know that this angle is 30. So if this is 30 and this is 90, this angle must be 60. So I've completed that triangle. Now, if this was something weird, you could take the arc sine of the sine of X and then take the arc sine of 1/2. So that undoes each other. And then I'll have the arc sine of 1/2. 1/2 is going, oop, what have I done? Is going to be 30 degrees. You can't see. All right, so the arc sine of 1/2 is 30 degrees. So, knowing your unit circle comes in handy. So I've got a right triangle. I have no idea if you even saw that problem. Let me just show this to you. Yes, you did. Okay, you can see the calculator, but you saw the problem. All right, so a right triangle has an hypotenuse of 7 inches. So here's my right triangle. I'm going to draw a little bit bigger so you can see a little bit better. It has a hypotenuse of 7 inches. Okay, if one angle is 35, find the length of each leg. So if this is 35, it does not matter which one you make 35. Then this one must be 55. So this is 55. And then we're just going to go through and use trig functions. So again, once I find one more side, I can either use Pythagorean theorem or I can use another trig identity to find my answer. But I'm going to go ahead and say that the sine of 35 degrees is going to be y over 7. And then I can multiply both sides by 7, and I'll know what y is. So 7 times the sine of 35 is going to give me 4.02. So this side is 4.02, and then if I wanted to, I could do cosine. So I could say the cosine of 35 degrees is x over 7, which means 7 times the cosine of 35 is going to give me my other side, which is 5.73. So 5.73, or you could have used 5.73. You could have used Pythagorean theorem and done 49 minus the square of this is the square root of that. So whatever makes you happy. All right, so I've got a tower that is 124 feet tall. So this is 124, and it casts a shadow 165 feet long. So there's my shadow. Find the angle of elevation of the sun to the nearest degree. So basically we're saying this is the sunbeam coming down. So if there's a little man standing down here and he's looking up towards the sun, which you should not do, what angle is this? How far up does he need to raise his eyes to see the sun? So what do I know? I know that the tangent of this, because this is my right angle, since we're assuming that the building is vertical, I know that the tangent of that angle is opposite over adjacent. So the tangent of that angle is opposite over adjacent. And now I need to know how to get to that angle. So take the arc tangent of both sides. So the arc tangent, and remember, you can write the inverse tangent, or you can write arc arctangent, and I'm just abbreviating it a little bit further, and I'm just putting atan. So this is the arctangent. So the arctangent undoes the tangent, and I end up with x equals the arctan of 124 over 165. 124 over 165. So the arctangent of 124 over 165 gives me 37 degrees. So basically, the angle of elevation to the sun, this little man is going to have to look from dead across at 0 degrees. He'll have to raise his eyes 37 degrees to look up to see the top of the building and the sun. All right, I have a laser beam. So, oh, there's a gnat. Get out. All right, so a laser beam is this long, which is 37 feet. And I am supposed to go through the center of a disc that has a radius of 12 feet. So this thing has a radius of 12 feet. Okay, so the origin of the beam is 37 feet from the circle. At what angle of elevation should the beam be aimed to ensure it goes through the hole? So if this radius from the center of that hole to the edge of the disc is 12 feet, that means it's also 12 feet this way. And so what I have, if I erase my little donut right here, is I just figured out that this height right here is 12. So I want to know what my angle of elevation is, and this is 90 degrees. So again, I know that the tangent of that angle is going to be opposite over adjacent. So I'm going to take the arctangent of both sides, and I get 12 over 37 equals x. So I took the arctangent of both sides. So taking the arctangent of the tangent makes you solve for x, and that means I've got to take the arctangent of the right side as well. So the arctangent of 12 over 37 gives me 18 degrees. It's right at 18 degrees. So that is my angle of elevation. So now we're going to look at a state trooper. And the state trooper is hiding behind a rock. I'm just going to show you the picture. Okay, so the state trooper is hiding 30 feet from the highway. And I know that as he tracks people, it takes 1 second for this truck to go from here to here. So 1 second is not a distance because we're dealing with feet. Okay, so we're going to figure out what this question says. So first of all, I know that this is 30. And I'm going to go from here. And then I've got that right there. All right, so this is my little truck. And then this is the police or the trooper. All right, if the angle measures 15 degrees, so this is theta. If the angle measures 15 degrees, how fast is the truck traveling? So remember that this width right here is how far he travels in 1 second. Okay, so I need to convert this into feet per second, which is what it's going to be figured out as, and then I'm going to convert it into miles per hour. So first of all, I'm told that this is 15. So I've got 15 right here. I know that this is 90 degrees. So I have the tangent of 15 degrees is opposite over adjacent. So I'm trying to solve for x. So I'm going to multiply both sides by x. So that gives me 30, and then I'm going to divide both sides by tangent 15, which remember is the same thing as multiplying by cotangent. Okay, so I've got 30 divided by the tangent of 15 means I've got 112, and I'm going, what am I doing? 2 decimal places. All right, so he is going 111.96. Remember, this is how far he travels in 1 second, and I'm measuring in feet. So this is going to be 111.96 feet per second. Okay, so from there, I want to convert into miles per hour. So I need to cancel feet. So I need to have a unit. I know that 1 mile has 5,280 feet in it. So at this point, my units, feet and feet, will reduce. And remember, this is the same thing as what we do with like pi over 180 or 180 over pi. It's the same thing as 4/4 over 10 dimes. Okay, it's still $1. They just look completely different. So this is still a ratio of 1. It's just weird. All right, so I've introduced miles. Now I need to get rid of seconds and introduce hours. So I want to get rid of seconds. So seconds will be on top and hours will be on bottom. So how many seconds are in an hour? We've got 3,600 seconds in 1 hour. So now my seconds reduce with my seconds, and I end up with a 111.96. So 111.96 times 3,600, and I'm going to divide that by 5,280, and I get he's going right at 76 miles an hour. So 76.34 miles per hour. So this is my first one, 76.34 miles per hour. All right, so let's change it up for just a little bit. What if I increase this thing to 31 degrees? So this is now 31 degrees, and I want to know how far he's traveled in 1 second. So my setup is going to be the same. I'm going to have the tangent of 31 is going to equal opposite over adjacent. So I'll have 30 over x. So multiply both sides by x. And then divide both sides by the tangent of 31. So I have x equals 30 over the tangent of 31. So if you think about this, for me to have this set in stone and unmoving, for this angle to be wider, I'm going to have to be closer. Okay, so he's going to cover less distance than he was if that space was longer. So I've got 30 divided by the tangent of 31, and I get 50 miles an hour, or 49.93. What did I just say? Sorry, that's feet per second. 49.93 feet per second. Feet per second. So he's doing roughly 50 feet per second, whereas up here he was doing almost 112 feet per second. So how many miles per hour is that? So I can use this same ratio right here. So I'm going to multiply by 3,600 and divide by 5,280. So 49.93 times 3,600 divided by 5,280 is going to give us our conversion for miles per hour. So times 3,600 divided by 5,280 gives us 34 miles an hour. Okay, 34.04 miles per hour. Okay, so now let's look at this for just a second. If we had a smaller angle at 15, he was going faster. If I had a larger angle at 31, he was going slower. So if the speed limit is 50 miles per hour, and a speeding ticket is issued for speeds of 10 miles per hour or more over the limit, for what angles should the trooper issue a ticket? Okay, so I need to figure out, first of all, I'm in feet. So I need to convert 60 miles an hour, because that's going to be the magic number. I want to convert 60 miles an hour into feet per second. Okay, so 60 miles an hour. I need to kill off miles. So 1 mile is 5,280 feet. So now I've killed off miles. And now 1 hour is going to be 3,600 seconds. So I do know that I've now converted this into feet per second. So 60 times 5,280 is, and then, you can't see, and then I'm going to divide that by 3,600. So I get 88. That's awfully friendly. All right, so according to my cool little triangle right here, this is theta, and I found out this was 30, and this is a very nice, pretty 88. So remember that the smaller that angle is, the faster he's going. Okay, so I'm going to set up a less than problem, but I do know that the tangent of that angle is going to be 30 over 88. So remember, you're in feet per second, feet per second. So I'm going to take the arc tangent of both sides, which will tell me what theta is. So the arc tangent of 30 over 88, let me just rewrite that because it's really messy. The arc tangent of 30 over 88 will tell me the biggest angle I can have. So the arc tangent of 30 over 88 gives me a degree measure of 18.82. So 18.8. Theta is 18.8 degrees. Anything from 18.8 and smaller means that he's speeding, going 10 miles over. So we'll do the last few examples. I'll set just a few more up in a third video.